Okay, in this video we are going to be looking at polynomials. We'll define them a little bit, we'll evaluate them, we'll maybe do a bit of simplifying and also classifying. Main thing is though we're talking about polynomials. So first question probably is, what is a polynomial? I looked online and there's a ton of different definitions of a polynomial. The way I see a polynomial though is it's some kind of expression that includes numbers, letters, powers, so numbers, letters, or variables, and powers. And typically you have some terms, and in between terms you have an add or a subtract. So for example, x plus 3, that's a polynomial. It has a number, it has a letter, or it doesn't have a power. Well, it doesn't matter. You can have any one of those things, or two, or all three. Doesn't matter. I could maybe have x squared plus 5x plus 6. That would be another polynomial. Or strictly speaking, you could say that 2 is a polynomial. Notice that this one here, there's just one number. Here I've got two things. And typically we call those things terms. And each term then is separated by an add or subtract. So maybe I could have put a subtract in there. So in this one I'd have 1, 2, 3 different terms. But all of those are termed a polynomial. So we've also given some names to some of the things. Typically a monomial is an expression that only has one term in it, like x, or 2, or negative 5x, or 7x squared. Each of those by themselves would just be a monomial. A binomial is one that you'd have two terms, like there's a binomial right there. A trinomial is three terms. Looks like that's a trinomial right there. This one only has one term, it would be a monomial. Okay, so when we have these polynomials, the power of them is that all of these variables represent something, and they can represent anything. And these expressions that we have, we can use them to express or describe lots of different real world kind of situations. And if we're doing that, then the x becomes some kind of a number. So in this question they say, what is the polynomial when x is a negative 3? So I can take this polynomial and evaluate it for x is minus 3. Or I could do 2. Or I could do 20. Or any number that I want, I could plug in for the x. Let's do the negative 3 though. When I'm doing this, I like to go negative 4, and wherever there's a variable, I put in a bracket. And then I'll substitute in what the variable is. And then I'll use order of operations to finish it off. So this is times between those. So negative 4 times negative 3 is a positive 12. Take away 7. In the end, the value of this polynomial here, when you plug in a negative 3, comes out to being equal to 5. Maybe try the one below for, let's say x is equal to 2. Evaluate that for x equals 2. Press pause, press play again when you're ready. Okay, if you put a 2 in, there'll be a 2 cubed plus 7 times 2 plus 10. Order of operations says do as exponents, so 2 cubed would be 8. So I'd have minus 5 times 8 plus, might as well do that, that's 14 plus 10. Minus 5 times 8 be minus 40 plus 14 plus 10. Okay, minus 40 plus 14, I think that's negative 26 plus 10. Down 26, gain 10. I'm still going to be in the whole 16, so negative 16. So the value of this expression when x is equal to 2 is a negative 16. Here's just a quick example, and I guess you could try this one. Concentration of glucose in the bloodstream after a certain number of hours, shown by this formula. So find the concentration after 5 hours. So what you do is you take and you write the whole formula down, but instead of the t, I put a bracket. Squared plus 3 times something plus 2. And then Of course, I'm going to plug in my 5 everywhere I see a t, and I'll go and finish evaluating that. I'd have to square this first, multiply it, add this, plus 2. Okay, you can do that. Okay, so often when we have a polynomial, we need to be able to describe it or identify certain things. So like I was saying before, this polynomial here, it looks like they have one add and one subtract. So these things separate terms. So in this polynomial, I have 3 terms of that particular one. 2x squared, negative 5x, and positive 2 are my 3 terms. This one I would call a trinomial. This one here, 4 terms, I don't know what you'd call that. Quadrinomial maybe? But you'd have one term there, term there, term there, and a term there. When I'm looking at terms, sometimes in an expression, I will want to collect like terms. So in this case here, again, I've got 1, 2, 3, 4 terms. And if any of the terms have the exact same letter and power, I can call those like terms. So these guys here, this one and this one, are like terms. These ones aren't the same because the x isn't the same in both of them. Take a look here and see if you can identify the like terms. Yeah, so this one would hook up with that one. Maybe a t squared would hook up with that one. Those two are like. And a t just by itself, it doesn't have a buddy. So it wouldn't have a like term. But those other ones did. Also, when you're looking to describe the terms, we often talk about coefficients. And usually if we just use that term, we're meaning the number out front of a letter. So if I look at this whole expression here, 4 terms, looks like these first 2 are like terms. But of these 2 terms here, this number out front is the coefficient. So the 2 is the coefficient of x squared. Negative 5, coefficient of this x squared. Positive 2 is this coefficient. This one, it doesn't have a letter. You could call 5 a coefficient if you want. So for this one, 5 minus 6. Notice the sign in front goes with it. 8, 14, negative 5. Those would be the coefficients for that expression. Now, knowing what those coefficients are help us when we are collecting like terms. Because when we collect like terms, what we do is we add or subtract their coefficients. So when I look at this expression, here this one is the same as that one. They're both x squareds. So I can add or subtract their numbers out front and then leave the coefficient alone. So I'm up 2x squareds, I lose 5x squareds, so now I'd be down 3x squareds. Notice I didn't do anything to the variables, I just left them as x squared. There's nothing that goes with this, so I would just have to leave it. Same thing with the plus 5. Try collecting these like terms and see what you come up with. Okay, so this one goes with that one. I'm up 5, I gained 14, so I'd have 19t cubed. Let's do t squared. Oh, here's a t squared. So these are like terms. Down 6 t squareds, gain 8, so I'd be up 2 t squareds. So I've taken care of all of those. It looks like this guy's out by himself. We'll just leave him there. Okay, so that's collecting like terms. The main thing is the variable part has to be identical. Sometimes when we're using polynomials, we want to put them in a specific order. And I guess it makes sense. So when I look at this polynomial, it irks me because this one has a higher number there than this one. And the rule is whatever the highest degree is should go first. So for this one here, I'd want to rearrange this polynomial so the minus 5x cubed goes first. That one we'll see again in a second, but that has a higher degree than this one. So this one would go first, and then the 2x squared would come, positive 2x squared. Then, yeah, this one would go, the 5x, and then the plus 2. So now that polynomial is written in descending order. We don't. I guess it's nice to do that. It's proper to write your polynomials in descending order. If you have them mixed up a little bit and they say that they don't care if it's in descending order, that's fine. But it turns out that in some operations like synthetic division, you have to have things in descending order for things to work. Try and do that one down there in descending order. Press pause and then go again. This one looks like the biggest number, so it'll come first. Done with that one. Then this one, so plus 8t to the 4th. That one's done. This one, the cubed, minus 5t cubed. Okay, so that one's done. And then this t squared one, minus 6t squared. That one's done. 14 and minus t. The t one has to come next. That one's done, and then the plus 14. So now they are in descending order. Okay. Related to that descending order thing is when you look at a polynomial like this one, sometimes we want to know what degree it is. The degree refers to the highest power that you have. So if this one, if I write this in descending order, 2x squared plus 5x plus 2, so if it's in descending order, this highest power right there tells me what degree the polynomial is. So this one here, I would say, is a degree 3 polynomial. Knowing that it's a degree 3 actually tells me what the graph of this would look like. This particular one, if I were graphing it, would start up here and do something like that. It would have that kind of shape to it. Take a look at the one below. What degree would that be? Again, hopefully you're looking here. You see a 5, a 2, a 4, nothing there, a cubed, and a 1 there. And you look for the highest one. It would be that one right there. So this polynomial would be degree 5. And again, if you wanted to take a look at what it looked like, that one would look something like that. Not exactly like it, but it would have that kind of shape to it. Okay, last concept. Sometimes you're given a polynomial where one of the terms might be missing. So if I take a look at this one, I've got a 5x cubed, that's the highest one, but I don't see a squared in there. And usually we go down, right? Like this one that we had here, 3, 2, 1. And this one, if I wanted to, I could write x to the 0 on it. So notice it's a descending degree. So if I have a polynomial like this one where I'm missing one of the terms, if I want, I could write it in. So 5x cubed, there's not an x squared term, so I could say there's 0 x squared terms, plus 5x plus 2. So I could rewrite that in descending order and include that missing term. Try that with the next one here. Hopefully you notice that right there there's no p term. So you could write this as negative 3p cubed plus 2p squared plus 0p, that's the term that's missing, plus 9. Okay, that gives you just a quick summary of polynomials, what monomials, binomials, trinomials are, what the degrees are, what coefficients are, what terms are, and maybe how to collect like terms, and to write polynomials in descending order. Hopefully that gives you a good start, and now you are free to try some questions.